Hello, my name is Dr. Alexander Stening. This is a synthesized and abbreviated recording of my speech at the TOC conference in Rotterdam in July 2019. Lifting containers up and down consumes a lot of energy. Moreover, a lot of this energy can be recovered. Here at Cascade Drives in Sweden, we have developed a powerful linear actuator for this job. In the video we saw forklift, but the technology is equally suited for an empty container handler. Existing hydraulic systems are not suitable for electric use. We now have the technology to replace critical hydraulic subsystems with electromechanical actuators, systems like a spreader, lifting, tilting, and tipping. The maximum force we can transfer from a pinion to a rack is determined by the contact surface. Increasing the force means increasing the pinion diameter, which drives the weight and therefore inertia. What you get is a bulky and slow-reacting system. At Cascade Drives we have a patented technology where we apply several pinions on one single rack. This is possible due to flexible elements inside the pinion. We can therefore ensure an equal load distribution between all the pinions. To increase the load, we increase the number of pinions. A consequence of this is that, unlike any other mechanical actuator, we can handle shock loads. This is very important in power steering and other rough environment applications. Most current actuators are limited in that they can either operate at high speed or a high load, not in combination. By using our multi-pinion technology, we can do both at the same time. These are the result from one of our case studies of an empty container handler. In this study we compare a hydraulic and an electromechanical lifting device. These are the results of the electromechanical lifting device when lifting and lowering an empty spreader. We are lifting and lowering at 0.6 meters per second, which gives us an input power of roughly 40 kilowatts. The lower left diagram shows the energy consumption during a full lifting and lowering cycle. As we lower the spreader we can regenerate about 60% of the energy used during lifting. We now compare the energy used by hydraulics to our electromechanical actuator when stacking containers. This is when you lift an empty container and lower an empty spreader. For an empty standard container weighing 3,750 kilos, we can expect an energy saving of 40 to 60% compared to hydraulics. In this picture, we lift the spreader and lower an empty container. For this scenario you can expect energy savings above 100%. This means that the cycle does not consume any energy. Stacked containers essentially become an available power source for charging your battery. Looking at a typical scenario, with both stacking and lowering containers, you can expect an energy savings of 68% when compared to hydraulics. This translates into an increased vehicle operating time of 38%, a significant improvement. So replacing hydraulics with electromechanical components can be an important step toward a green port. Thank you.